Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stat at math at University of Toronto. Today we'll be going over some commonly asked math questions at both the high school and college levels. If you need some homework help or tutoring, please check out the links in the description below. Okay, so now let's start our session for today. Alright. So our first question is asking us to write a polynomial in standard form. So write the polynomial in standard form, and we need to identify the degree of the polynomial, and we also need to identify the leading coefficient, and then we need to classify it according to its degree and number of terms. Okay, so first let's recall what standard form is. Standard form. Okay, so standard form of a polynomial is writing in descending order from left to right. Okay, so writing in descending order from left to right, the degree of each term according to the degree of each term. Okay, so the standard form of 3x squared minus 8x minus 5x cubed plus 6. If we want to convert this into its standard form, then it should be standard form. Okay. Then it should be negative 5x cubed, since this term had the highest degree, and then plus 3x squared, since 3x squared had the second highest degree, and minus 8x, and then plus 6. Okay, yeah, so that's what a standard form should looks like. Okay, and when you look at the coefficient, I mean the exponent, you can see here we have x cubed, and here we have x squared, here we have x, and for the constant, the exponent will just be 0. Okay, so next we need to find the degree of the polynomial. Okay, so let's copy this part down. Okay, so degree of the polynomial. Polynomial. Okay, so in this case, the degree of polynomial should be 3. Okay, since the highest exponent found in the first term of the polynomial in standard form is 3. Okay, and let's write the reason here. Reason. Since the highest exponent found in the first term of the polynomial in standard form is 3. Okay. And this 3 is from the negative 5x cubed, so the exponent. Okay. And after identifying the degree of polynomial, next we need to do the leading coefficient. Okay. So in terms of leading coefficient, the leading coefficient should be negative 5 in our case, and the reason is that negative 5 is the coefficient attached to the variable that has the highest degree. Okay. So in our case, the variable had the highest degree would be negative x cubed, and in this case, negative 5 will be the leading coefficient, since it is a coefficient attached to the variable that has a highest degree. Okay. And lastly, we will write the polynomial. Polynomial is a cube polynomial. Okay. And the reason why is that since it has it's of degree 3 and that's 4 terms. Okay. Yep. So that's what we have for this question. And let's just review this again. So first, we identify standard form. So in other words, we need to write in descending order from left to the right according to the degree of each term. Okay. And then in terms of the degree of polynomial, in this case it will be 3, since the highest exponent found in the first term of the polynomial in standard form is 3. Okay. So the keyword will be the highest exponent. Okay. And for the leading coefficient, it is just a coefficient attached to the variable that had the highest degree. Okay. And lastly, the polynomial is a cube polynomial. Okay. Let's leave a comment. Solution is correct. Well done. Okay, so for next question, we will talk about the algebra properties. So what are the algebra properties? Okay. So in terms of the algebra properties, there are 9 basic properties. So let's start with the first one, which is commutative property of addition. Commutative property of addition. Okay, so this property states that rearranging the order of sum won't change the final answer. So, in other words, x plus y will be equal to y plus x. Okay, so an example could be 5 plus 3 is equal to 3 plus 5. Okay, and so let's say we have a question asking you to calculate 999. Oh no, let's do let's do 123 plus 999 plus 1. I mean, if we follow the regular order, we will group the first two, which is somehow hard to calculate our answer. But if we calculate these two first, we can have 123 plus 1000, and that gives us 1123. So that somehow help us do the calculation. Okay, so that's commutative property of addition. And secondly, we have commutative property of multiplication. Okay, so similar to the property of addition, they state that rearrange the order of product won't change the final answer. So in other words, A times B is the same thing as B times A. So 5 times 3 is equal to 3 times 5. Okay, and next we have the associative property of addition. Associative property. And in this case, if we have x plus y plus z, if we group the first two, it will be equal to the answer of grouping the last two terms. Oh, and the example I give above should follow the associative property of addition instead of the commutative property of addition. So let's write that down again. If we have 123 plus 999 plus 1, if it follows a regular order, so we need to group the first two, which is somehow hard to calculate or wasting time. So by knowing associative property of addition, we can group the last two terms first. So we have 123 plus 999 plus 1, which becomes to 123 plus 1000, which gives us 1123. Okay. Yep. So that's how we use the associative property of addition. And similarly, there are also going to be associative property of multiplication. Multiplication. Okay. So yeah, so similar to the addition one. So this state that regrouping terms of product won't change the final answer. Okay. So x times y times z is equal to x times y times z. Okay. So you can either group the first two, or you can first group the last two. Okay, so next we have distributive property. Distributive property. So for this property, it states that a sum or a difference expression multiplied to a constant is equal to the sum of difference of each terms multiplied with that constant. So if we have x times the sum of y plus z is equal to xy plus xz, okay? So we are distributing x to y and to z, okay? So an example could be let's do 4 times 20 plus 5, okay? So this would also be equal to 4 times 20 plus 4 times 5, okay? And which is equal to 80 plus 20, which is equal to 100, okay? And in our case, 4 will be x, 20 will be y, and 5 will be z, okay? So after applying the distributive property, we have x times y plus x times z, okay? All right, so next we have identity property of addition. Identity property of addition, okay? And this property states that any number added to 0 is equal to the number itself. Okay, so that means x plus 0 will be equal to x. Okay, and next we have identity property of multiplication. Okay, so this states that any number I'll write it on here. So any number multiplied by 1 is equal to the number. Okay, so if we have x times 1, that will also be equal to x. Okay, and number 8, we have the inverse property of addition. Inverse property of addition. Okay, so they state that a number added to its inverse is equal to 0. Okay, so a number added to its inverse is equal to 0. Okay, so in other words, x plus negative x will be equal to 0. Yep. And last one, we have inverse property of multiplication. Okay, and this is given by a number multiplied by its inverse is equal to 1. So which means x times x to the exponent of -1 is equal to 1. Okay. Yep. So those are the 9 basic algebra property. Okay, so let's leave a comment. So solution is correct. Well done. Okay. So next we have a question asking us how to find the area of a regular polygon. Okay. So finding area of irregular polygon. Okay. So in order to find the area of irregular shapes, it is very important to first divide the irregular shape into recognizable regular shapes. Okay, so the key is divide or separate the irregular shape into regular shape. And by saying regular shape, we're talking about triangles, rectangles, circles, square, etc. And let's try with this example. Example 1. Okay, so let's say we have this irregular shape. Okay, that's 8, 5, 2, and 4. Okay, and we need to find out the area for this irregular shape. So remember what we said earlier, we need to divide the irregular to regular shape. Okay, so we can know that in this particular shape, it contains 2 recognizable shapes, and which are 2 rectangles, and we just need to find the area of each of those 2 shapes and add the result. Okay, so if we draw a line right here, then we will see that's rectangle 1 and rectangle 2. Okay, and therefore the area of rectangle 1 will be, oh, first we need to figure out the length for this. So that's just going to be 8 minus 5, which is 3. Okay, so the area 1 should be 3 times 4, which is 12. And for the area for the second triangle, we're just going to be 2 times 5, which is 10. Okay, and the last step will be just adding them together. So irregular shape area will be equal to 12 plus 10, which is equal to 22. Okay, so that's how we find the area for irregular shapes. And let's try another example. Okay, so something look like this. So that's 3, and that's 5. Okay. So the figure about has 2 shapes as well. So we have a half circle and a rectangle below it. So a circle, actually half circle plus rectangle. Okay, so we just need to calculate the area of the half circle and the area of the rectangle. Okay, So in terms of the half circle, it is given by 1 over 2 times pi r squared, which in this case will be, uh, let's use 6. Okay, because if the diameter is 6, then the radius will be 3. Okay, so pi 3 squared over 4, which is 3.53. Okay, and for the rectangle, that will be 5 times 6, and which would be 30. And then we just add this 2 together to get our final answer. Okay. So solution is correct. Well done. Alright, so I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you would like to submit your own questions, please read the links in the description. Remember to leave a like and a comment and share this video with your friend. This has been Andrew from OneClass. I hope to see you soon. Bye.